Alright, in this video we're going to be looking at section 3.3. This deals with dividing polynomials and the remainder and factor theorems. And in this video we're going to be talking about how to use synthetic division to divide polynomials. Also, we're going to be evaluating polynomials using the remainder theorem, evaluate a polynomial using the remainder theorem, and use the factor theorem to solve a polynomial equation. Okay? Now, the reason why I don't want to cover long division in this video, because long division is a bit time consuming, especially when you're dealing with polynomials. So the quick way of doing that would be to use synthetic division. So on page number 1, you'll see the method for dividing polynomials using synthetic division. Now here we can use synthetic division to divide polynomials if the divisor is of the form x minus c. Now this method provides a quotient more quickly than it would if you were to do the long division method. Now, let me tell you that the synthetic division is only effective if you have x minus c. So, to do something like x squared minus c as your divisor, then you'll have to use the long division approach. And I did create a video for this section as well that has long division done on there as well. Alright, now on that first page you'll see the blue box representing the synthetic division approach. So to divide a polynomial by x minus c, we have to do these seven methods, or 7 steps. Number 1, you want to arrange the polynomial in descending powers with a 0 coefficient for any remaining, any missing terms. Okay, so if you're missing something like an x cubed or an x squared, you have to compensate that with a 0 coefficient. And then you're going to write the divisor c for that divisor x minus c. So to the right, you'll write the coefficients of the dividend. So in this case, I got x cubed plus 4x squared minus 5x plus 5 divided by x minus 3. You can see that the powers are in descending order from highest to lowest. Now, we write down their coefficients. For the x cubed, that coefficient is a 1. For x squared, the coefficient there is 4. For x, the coefficient there is 5. And for positive 5, that's a constant. Now, to get the divisor, which is x minus 3 in synthetic division form, what I would do is take that divisor of x minus 3 in this case, set it equal to 0, and solve for x. And that will tell you what the divisor is. In this case, your x is going to be equal to 3. So your 3 will be your divisor here. And now the next step, step number 3, is to write the leading coefficient of the dividend in the bottom row. So this 1 is your leading coefficient. I'm going to write that down in the bottom row. And then step number 4 is to multiply the c, which is in this case the 3, by the number that I wrote down in the bottom row. So I'll do 3 times the 1, that's going to be 3. And then you're going to add that number add the values in that new column, and you're going to write the sum in that bottom row. So if I add 4 plus 3, I'm going to get 7. And also notice where the 3 is written. It's not written underneath the 1, it's underneath the 4. So add 4 plus 3, you'll get 7. And then you're going to repeat this series of multiplications and additions until all solutions are filled in. So in this case, if I do 3 times the 7, I'm going to get 21. That will go underneath negative 5. add negative 5 and 21, you'll get 16. And then continue on by doing 3 times 6, 3 times 16, that would be 48. And add 5 plus 48, you'll get 53. So all the multiplications and additions are done there. And now we're going to write the quotient and the remainder. Now, in this case, step number 7, you're going to use the numbers in the last row to write the quotient plus the remainder above the divisor. The degree of the first term of the quotient is 1 less than the degree of the first term of the dividend. If we start off with an x to the third, then that means that 1 will be your coefficient for x squared. And then the powers start descending. But keep in mind, the last number in the last row represents the remainder. So that 53 will be over x minus 3. And the quotient will be 1x squared, or just x squared, plus 7x plus 16. Okay, now, on the next page, you're going to see a comparison of long division with synthetic division. You can obviously see that doing the synthetic division process is much easier to do it this way than it is if you were to do it with the long division. But you have to know that the last number in the last row represents the remainder, and the other numbers are going to be the quotient. So the 16 will be a constant. This 7 will be the coefficient of x, and the 1 is the coefficient of x squared. If there was another term in front of that, it would be the coefficient of x cubed. That will help you write down your quotient. So let's do an example of this. In example 1, you want to use synthetic division to divide 5x cubed minus 6x plus 3x plus 11 by x minus 2. Well, my divisor in this case is x minus 2. So I need to find out what that divisor is going to be in the synthetic division process. So I'm going to take x minus 2, set that equal to 0, and solve for x. That would mean x will have to be equal to 2. So that divisor there will be 2 for this synthetic division. So the 2 will be on the left. Now I need to look at this dividend right here, 5x cubed minus 6x squared plus 3x plus 11. There are no missing terms here. I got an x cubed, x squared, x, and a constant term. So I can write down their numerical coefficients. So the coefficient of x cubed is 5. For the x squared, that coefficient there is negative 6. For x, that coefficient is 3. And 11 for the constant term. So now we start this synthetic division process here. Notice I put a box right here to separate the quotient from the remainder. Okay? So the first step is to bring down the leading coefficient, which is your 5 for this problem, in the bottom row. And then I'm going to multiply this 2, which is my divisor, times the number in that bottom row, which is your 5. So I'm going to do 2 times 5, that's 10. Now that 10 is going to go right here, where that negative 6 is. And then I'm going to add negative 6 to 10, I'm going to get 4. And now I'm going to repeat this until all the columns are filled. So I'm going to do the divisor of 2 times that 4, which will give me 20. And then add 3 plus 20, you'll get 23. And then finally, multiply the 2 times 23. That will be 46. And in this case here, if I add 11 and 46 together, I'm going to get 57. Okay. So now I'm done with this. Now I need to write the quotient and the remainder. That 57, which is the last number in the last row, that's going to be your remainder. The other numbers, 5, 4, and 23, will be your quotient. The 23 will be the constant term. The number in front of that, which is your 4, that's the coefficient of x. The 5, which is in front of that, would be the coefficient of x squared. So this is what the quotient and the remainder would look like. 5x squared plus 4x plus 23. And then the remainder would be plus 57 over the divisor, which is x minus 2. Now normally I would entertain questions, but since it's on videotape, if you do have questions, do email me or contact me if you have questions about this. Alright, here's another example. Let's say I got x cubed minus 7x minus 6. And I want to divide that by x plus 2. Well, let's take that divisor of x plus 2, set it equal to 0, so that I can find out what my divisor will be in synthetic division. So if I subtract 2, you'll get x is equal to negative 2. So I know negative 2 will be my divisor. But let's look at a dividend of x cubed minus 7x minus 6. I got an x cubed. However, I'm missing an x squared term. So I have the x cubed, but I'm missing an x squared term. So this will be minus 0x squared plus minus 7x minus 6. By the way, that's a minus sign. So now I can write my coefficients here. For the x cubed, it's going to be 1. The x squared term is missing, so that's a 0 for that. The x will be negative 7, and then negative 6 for the constant term. And now I'm going to bring down the leading coefficient of 1 in the bottom row. So now if I multiply the negative 2, which is my divisor, times the number in the bottom row, that's the 1, negative 2 times 1, that will be negative 2. Now that negative 2 has to go underneath the 0. So here if I add 0 and negative 2, I'm going to get negative 2. And then repeat this until all the columns are filled. That negative 2 times this negative 2 would be a positive 4. And then add negative 7 and 4 together, you'll get negative 3. And then finally, negative 2 times negative 3. The divisor times that number. That will give me a positive 6. And then negative 6 plus 6 is 0. And we're done. So now we have to write the quotient and the remainder. Well, notice the remainder is 0, so I don't need to write 0 over x plus 2. But for the 1, negative 2, negative 3, that's the quotient. Your constant will be negative 3. The negative 2 is the coefficient of x. The 1 is the coefficient of x squared. So I'm going to have 1x squared, or just x squared, minus 2x minus 3. And that plus 0 over x minus x plus 2 will not be necessary because the remainder there is just simply 0. So we just need to write the quotient. And I think in the homework, they want you to give two separate answers. One would be the quotient and the other one would be the remainder. This would be your quotient. The remainder would be 0. So like in that first example that I just did, that 5x squared plus 4x plus 23, that would be your quotient. The 57 will be your remainder. Alright, here's another example. Dividing using synthetic division. Here we got 5x to the 6th minus 5x to the 4th plus 6x squared plus 6 divided by x minus 2. In this case, we do x minus, take that divisor of x minus 2, set that equal to 0, and find out what x is. So if I add 2, that's going to mean x is equal to 2. So that x equals 2, that 2 will be your divisor in the synthetic division. And just like in that last example, there are some terms that are missing here in this dividend. We got x to the 6. And if this helps, the highest is x to the 6. That means you must have a coefficient for x to the 5th, and then x to the 4th, x cubed, x squared, and x, and a constant. Notice we do have a coefficient for x to the 6. That's 5. We don't have a coefficient for x to the 5th, so that's going to be a 0 here. And then for x to the 4th, we do have a coefficient there, that's -5. For x cubed, there isn't one, so that's a 0 there. For x squared, there is 1, that's a 6. There's no coefficient for your x, that's 0, and then the constant will be 6. So that's what your dividend in the synthetic division would look like. And now we bring down the leading coefficient, which is a 5, in the bottom row. And then multiply the divisor times that number in the bottom row. 2 times 5 would be 10. And then we add 10 and 0 together. That would give you 10. And then repeat this until all the columns are filled. So here, 2 times 10 would be 20. And then add -5 plus 20, that would be 15. And then 2 times 15 would be 30. And then add 0 and 30, you're going to get 30. And then next, 2 times 30 will be 60. And then add 6 and 60 together, you'll get 66. And then 2 times 66, that's 132. Add 0 to that 132, you're going to get 132. And then finally 2 times the 132. This will be 264. And then add 6 to that 264, you're going to get 270. So now we're done with the synthetic division. Now we have to write this as a quotient and remainder. In this case, that 270 in that box, the last number in the last row, that is your remainder. Now, these other numbers, that's your quotient. So, here, the 132 is your constant term. That 66 would be the coefficient of x. The 30 in front of that would be the coefficient of x squared. The 15 would be the coefficient of x cubed. The 10 is the coefficient of x squared. X to the 4th, sorry. And then the 5 in front would be the coefficient of x to the 5th. So in this case, my quotient would be 5x to the 5th plus 10x to the 4th plus 15x cubed plus 30x squared plus 66x plus 132. And then the remainder of 270 will be over your divisor of x minus 2. Okay. So that's how we do synthetic division to divide polynomials only of the form x minus some constant. Alright, now synthetic division can be used in what we call the remainder theorem. So we'll quickly talk about that one. If the polynomial f of x is divided by x minus c, then the remainder is f of c. So this is one way of finding out the value of the function at some particular x value, as opposed to substituting each x with that value. We can use synthetic division and the remainder theorem. So in example 4, we're going to be given that f of x is equal to x cubed minus 7x squared plus 5x minus 6. And I want to use the remainder theorem to find f of 3. So here, my x value is 3. That's going to be the divisor. Not negative 3, because that f of 3 means the x value there is 3. And it's already solved for x, so we only use the positive 3 in this case. And then look at f of x. There are no missing terms here. I got x cubed, x squared, x, and a constant term. So I can go ahead and write down their numerical coefficients. So for x cubed, the coefficient there is 1. For x squared is negative 7. And then for x is 5. And then the constant term, negative 6. So now, I can bring down the 1, which is the leading coefficient in the bottom row, and then multiply this 3 times 1, which is 3. That goes underneath negative 7. And then add negative 7 to 3, you'll get negative 4. And then do 3 times negative 4. That's negative 12. And then add 5 and negative 12 together, you'll get negative 7. And then finally do 3 times negative 7. That's negative 21. So if I add negative 6 and negative 21 together, you'll get negative 27. Now, this last number in the last row is, of course, your remainder, the negative 27. Not only that, that represents the value of this particular function when x is equal to 3. So I can say here, f of 3 is equal to negative 27. F of 3 is equal to negative 27. Pretty much easy to do it this way when you're doing synthetic division than to substitute x in that function. Alright, example 5. Here we got f of x is equal to 3x cubed plus 4x squared minus 5x plus 3. And I want to use the remainder theorem to find f of negative 4. So that x value that we have is negative 4. And that's going to be the divisor for the synthetic division. So negative 4 will be to the left. If I look at f of x again, I have no missing terms here. I got x cubed, x squared, x, and a constant term. So, write down the numerical coefficients. For x cubed, it's going to be 3. For the x squared, it'll be 4. For the x, negative 5. And for the constant term, 3. So now, we bring down the leading coefficient of 3 in the bottom row, and then multiply the divisor times that number in the bottom row. Negative 4 times 3 would be negative 12. And then we're going to add 4 and negative 12 together. You'll get negative 8. And then next, keep this process going until all the columns are filled. Negative 4 times negative 8, that'd be 32. Add negative 5 and 32 together, you'll get 27. And then finally, negative 4 times 27. That would be negative 108. And then add 3 and negative 108 together, you'll get negative 105. So now, as you can see, the last number in the last row is that remainder. And not only that, it also represents the value of the function when x is equal to negative 4. So, f of negative 4 will be equal to negative 105. Okay. So that's how we apply the remainder theorem and synthetic division to find out the value of any function at any given value. Okay, next we'll look at the factor theorem. If we let f of x be a polynomial, then we got these two cases. In part A, if f of c is equal to 0, then x minus that constant is a factor of f of x. And conversely, if x minus c is a factor of f of x, that means that f of c must be equal to 0. That's what the factor theorem is. So here we're going to use that and synthetic division to solve these two problems, like in example 6. Here we're going to solve the equation 2x cubed plus 5x squared plus x plus 2 equal to 0, given that 2 is a 0 of that function f of x equal to 2x cubed minus 5x squared plus x plus 2. Well, if I know that 2 is a 0 of that function, that means f of 2 must be equal to 0. And that also means, by this factor theorem, x minus the constant, or x minus the constant, which is 2, is a factor of that function f of x. So to find the other factor, we need to use synthetic division. Well, if 2 is a 0 of this function, that 2 must be our divisor. And if you look at f of x, there are no missing terms here. That means we got x cubed, x squared, x, and a constant. So we can write down the numerical coefficients. So for the x cubed, it's going to be 2. For the x squared, negative 5. For the x, that's the understood 1. The constant term is 2. Alright, so we bring down the leading coefficient of 2 in the bottom row. And then we're going to multiply 2 times 2. That's going to be 4. And then add negative 5 to 4 together, you'll get negative 1. And then multiply that 2 times negative 1, that's negative 2. Add 1 to the negative 2, you're going to get negative 1. And then finally, 2 times negative 1 will be negative 2. Add 2 to this negative 2, you're going to get 0, which I would expect to get, because I know that 2 is a 0 of that function. That means the remainder has to be 0. So I know one of my solutions is 2, because 2 is a 0 of that function. To find out what the other zeros are, I have to look at this quotient right here and set that equal to 0. That 2, negative 1, negative 1. Here the negative 1 is the constant term. The negative 1 in front of that is the coefficient of x. The 2 in front of that is the coefficient of x squared. So here I'm going to have 2x squared minus 1x, or just x, minus 1. And that's going to be set equal to 0. Now that 2x squared minus x minus 1, I will factor that into 2 binomials here. That 2x squared, I'm going to break that up as 2x and x. The only factors of 1 will have to be 1 and 1, but the 1 has to be in a place so that the outer and the inner will have to be negative x. So if I make this one negative here and this one positive here, then that means minus 2x and a plus 1x will give me negative x. So here I got 2x plus 1 times x minus 1 equal to 0. And then I'm going to set these two binomial factors to be equal to 0. So here I'm going to have 2x plus 1 equal to 0 and x minus 1 equal to 0. And then solve for x. So if I subtract 1, I'm going to have 2x is equal to negative 1. Divide by 2. This x will be equal to negative a half. So I know one solution is negative 1/2. And then for the x minus 1 equals 0, well, let's just add 1. That means x is equal to 1. So these are all the solutions, or all the zeros of that particular function. That means x is equal to 2, x is equal to negative 1/2, and x is equal to 1. Okay, so that's example 6. And finally, example 7. Here we're going to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equal to 0. Given that negative 1 is a 0 of the function f of x equal to 15x cubed minus 14x squared minus 3x minus 2. Alright, in this case, I know that negative 1 is a 0 of that function. That means that f of negative 1 is equal to 0. And that would mean, by the factor theorem, x minus the constant, which is in this case x minus that constant, which is negative 1, or x plus 1, is a factor of the function f of x. And since negative 1 is a 0 of that function, I'm going to use negative 1 as my divisor. And in the f of x function, there are no missing terms. I get x cubed, x squared, x, and a constant term. So I can write the numerical coefficients here. So for the x cubed, that's 15. For the x squared, that would be 14. For the x, that coefficient is negative 3. The constant is negative 2. And now I'm going to bring down the leading coefficient of 15 in the bottom row and start multiplying -1 times 15, which is -15. And add -14 and add 14 and -15 together, that'll be -1. And then next I do -1 times -1, that will be 1. -3 times -3 plus 1, that's -2. And then finally, -1 times -2 will be 2. -2 plus 2, 0. I would expect to get a 0 here because I know I'm given that -1 is a 0 of that function. And I also know this as one of my solutions. It would be -1 because I'm given -1 is a 0 of that function. Excuse me. So that -1 and -2, that represents the quotient. And of course that -2 is the constant term, the -1 is the coefficient of x, that 15 is the coefficient of x squared. So I'm going to take that quotient of 15x squared minus 1x, or just x, minus 2. We're going to set that equal to 0. And solve for x. We're going to have to do some factoring here. Now that 15x squared, you're just going to have to take my word on this one. I'm going to break 15x squared as 3x and 5x. And then the only factors of -2 will be something like -2 and 1. If I make this a -2 next to the 5x and place the +1 next to the 3x, then 3x times -2 will be -6x. 1 times 5x will be 5x. -6x plus 5x will give me the -1x. So I get 3x plus 1 times 5x minus 2 equal to 0. And then I'm going to set each binomial factor equal to 0. So this will be 3x plus 1 equal to 0. 5x minus 2 is equal to 0. And then we'll solve the x. So for the 3x plus 1 equal to 0, if I subtract 1, I'm going to get 3x is equal to -1. Then divide both sides by 3. X will be equal to -1/3. So I know another solution is -1/3. And then for the 5x minus 2 is equal to 0. If I add 2, I'm going to get 5x is equal to 2. Divide by 5. You'll get x is equal to 2/5. So these are all the zeros for that polynomial function. -1, -1/3, and 2/5. Okay. Now I do want to remind you, if the factoring is giving you problems, there are YouTube videos out there that explain how to do various types of factoring. I know that Fourth End Tutoring has YouTube videos that explain factoring. You might want to go to that particular resource and watch those videos as well. Okay, so this will conclude this video on dividing polynomials using the remainder and factor theorems. The homework will be available for you to complete, and do email me if you have any questions about any of the problems that I discussed in this video.